Now we will solve some questions based on graphical finding of displacement, velocity, and acceleration. And to solve those questions, just remember the basic principle. Slope of a displacement time graph gives us instantaneous velocity. Slope of a velocity time graph gives us instantaneous acceleration. And if we need to go in the reverse direction, then we use area. So area under the acceleration time graph will give you change in velocity, whereas area under the velocity time graph gives us displacement. Let's solve the first question based on this principle. So here we have a graph where on the y-axis it is velocity, x-axis is time. So this is a velocity time graph for a car which is traveling along a straight and level road. And the question is, what time does it take for the car to travel a distance of 31.5 meters? If we go back to the logic, area under the velocity time graph gives us displacement. So in this question, velocity time graph is given. And if you try to figure out the area under this graph, that will give us displacement. But incidentally, it is mentioned that the car is traveling along a straight road. And the logic is whenever a particle is traveling in a straight line, distance and displacement are the same. So in this case, area under the graph will also give us distance. In this question, we are supposed to find that time when the distance traveled by the car is 31.5 meters. All we need to do is try to figure out the area under the graph. But there is no need to find the complete area of this entire figure. So we'll go step by step. So let's start with 0 to 2 seconds. So from 0 to 2 seconds, we can see graph is a straight line. We need to draw a line starting from this point, and that line should be perpendicular to the x-axis, and the line will look like this. And now we need to find the area under the graph. What do we mean by area under the graph? That would mean the area between the graph, the line which we have drawn, and the x-axis. So consider this triangle. This area is what we need to find. Area of the triangle, remember, is half base into height. Base of this triangle, as you can see, is 2 units, and height of the triangle is 4. So let's write down on the right hand side. Area of the triangle will be half base into height. Base is 2, height is 4, which means the total area comes out as 4. So let us write down the area for this right angle triangle is 4 units. Hence, distance traveled by the car in 2 seconds is 4 meters, which means option A is not the right answer because we want the distance to be 31.5. So let's go to the next option, 7 seconds. We need to check whether 7 seconds is right or wrong. We will use the same strategy. For 7 seconds, we go to the extreme end, this point, and we will draw a line starting from this point and perpendicular to the x-axis. So the line will look like this. And now we need to find the area of this complete figure. This is actually a trapezium. To find the area of the trapezium, either you can use the direct formula, or easier way is just divide this trapezium into two figures. We'll have a right angle triangle plus a rectangle. In this rectangle, the base of the rectangle, let's see, it is 7 minus 2. So 5 units is the base and the height is 4. 4 into 5 will give us 20. Hence, area of this rectangle will be 20 units. So let's write it down. Coming to the triangle, base of this triangle is again 5 units, 7 minus 2. But the height of this triangle will be 7 minus 4, which is 3. So let's write down the area for the second triangle will be half multiplied by 5 multiplied by 3, which comes out as 7.5 meters. Hence, in the area, let me write 7.5 over here. Now, let us try to figure out what is the total distance traveled by the car in 7 seconds. So that will be 4 plus 20 plus 7.5. So if we add all of these numbers, let's do that. 4 plus 20 plus 7.5. If we solve this, we will get 31.5 as the answer. And that is what we had wanted in the question. Distance traveled to be 31.5. And when does that happen? At a time of 7 seconds, which means option B is the right answer for this question. Here we have a graph which shows the variation of velocity with time. The truck is of a fixed mass. What can be deduced from the graph? So we need to figure out which statement is correct. Option A, the truck is always accelerating. Option B, truck is always moving. Option C is truck is moving in one direction. And finally, option D states that displacement of the truck after time is 0. So in an exam situations, you need to start with those options which are easier to handle. So in this case, if you look at option B, the truck is always moving, which means the velocity of the truck should not be 0 ever. Because if the velocity becomes zero, then the truck will become at rest. And let us check, is the velocity zero at any stage in this graph? So overall at t is equal to zero, you can see velocity is a positive value, which means the truck is moving to the right hand side. And then as time passes by, the velocity keep reducing until becomes zero. And this is that point where the truck is at rest. To be specific, it is at instantaneous rest, because afterwards you can see the velocity has become negative and the magnitude of velocity keeps increasing, which means the truck will reverse the direction. It was earlier going towards the right hand side. It stops for a moment and then it reverses direction and then it starts moving to the left hand side with increasing velocity. And since the truck was at instantaneous rest at this point, we cannot say truck is always moving. So option B is definitely incorrect. Truck is not always moving. Option C states truck is always moving in one direction. That is incorrect because we just proved that the truck was earlier going towards the right hand side. It stops and then it reverses the direction. And let me re-explain that. So if you consider this point where the truck is at instantaneous rest, if you go a little bit to the left hand side of this, velocity is above the time axis, which means velocity is positive. And if velocity is positive, that means the truck is moving towards the right hand side. Now consider the same point when the truck is at instantaneous rest. If you go a little bit to the right hand side of this, you can see the velocity becomes negative as the graph goes below the x-axis. Now, since the velocity is negative, that means the truck is going towards the left hand side. And that is why we can deduce that this point where the velocity time graph cuts the x-axis, this is that time when the particle truck in this case is reversing the direction. So please remember that as a rule, whenever you see a velocity time graph cutting the x-axis, that is the point where the particle is changing the direction. Hence, option C, which states that truck is always moving in one direction, that is incorrect. And now let us look at option D, the displacement of the truck after time. Is it zero? How do you figure out the displacement from a velocity time graph? The logic is area under the velocity time graph gives us displacement. And hence we need to find the total area under the graph from 0 to 2 seconds. So let us consider this point where the truck came at instantaneous rest. Let me label this point as point A. And on the right hand side, let me say it is point B. If you analyze the graph from 0 to A, we need to find the area under the graph. By area, we mean the area between the graph, the x-axis and the y-axis in this case. So let me shade that region. So area of this entire region will give us the displacement traveled by the truck in 0 to A seconds. A is that time when the truck was at instantaneous rest. And from A to B seconds, we need to do the same thing, area between the graph, the x-axis, and then this dotted line. So if I shade that region, this region will give us the displacement of the truck traveled between A and B. And if the question asks us to find the total displacement of the truck after time t, we need to add these two areas. So consider this region which I have shaded. Let's say the area for that is A1. Let me write this is A1 for instance. And the area on the right hand side, this, let's say this is A2. And now if we try to figure out the total area, that is just the addition A1 plus A2. But the question wants us to find the total displacement. What will we do there? So the total displacement will be A1 minus A2. So why are we taking a negative sign with A2? That is because the area A2 is below the x-axis. A1 was above the x-axis. That's why it was positive A1. A2 is below the x-axis. That's why we take a negative A2. Hence, the total displacement of the truck after time is A1 minus A2. Now, in statement D, it is saying that the total displacement is 0. Now, for the total displacement to be 0, A1 and A2 should be equal. Now, in the graph, we need to check, is it possible A1, A2 are equal? So, just from the looks, you can see this region is having a greater area than this region. So, A1 is greater than A2. Let me write it down. A1 is greater than A2, which means that the total displacement will be positive. It will be greater than 0. And that is why the statement D, the total displacement is 0, that is incorrect. Which means, of course, option A would be the right answer. But just for the sake of it, let us check. Option A states the truck is always accelerating. For this statement to be true, all we need to check is there should not be any point where acceleration is 0, since we are supposed to prove truck is always accelerating. Let me repeat, in order for the statement A to be correct, there should not exist any point where the acceleration is zero. And how do we find acceleration from the velocity time graph? Remember the logic? Acceleration is the gradient of a velocity time graph. And for the gradient to be zero, the tangent drawn to the graph should be parallel to the x-axis. And if you analyze this graph, there does not exist any point on this graph where the tangent drawn is parallel to the x-axis. Just for explaining, let me explain when can the tangent be parallel to the x-axis. So imagine the graph looks like this. So if you consider the topmost point, let me consider this point as P. And if we draw a tangent at that point, that will be the point when the tangent is parallel to the x-axis, and then we can see gradient of that tangent will be equal to zero. But incidentally, in this graph, there does not exist any point where the tangent becomes parallel to the x-axis, which means throughout this motion from 0 to A or A to B, acceleration is never zero. So let me write acceleration is not equal to zero throughout the motion, which means the truck is of course always accelerating. And hence we can say option A is the right answer.